All right, sampling distributions. I'm going to go through this relatively quickly here. Um, Pause, re-listen as you need. There are several key concepts that are not necessarily difficult. There's a lot of words. I'm going to say sample and statistic and distribution and mean in all sorts of different mixed up ways, which is going to potentially seem confusing. And I'm going to try to make it as simple as we can. But we're gonna start by setting the stage here. Suppose we have a population of 5 students who all took this Unit 4 test, and these are the grades that they made conveniently: 60, 70, 80, 90, and 100. Make a dot plot of the population distribution. So I have the filled in version here that I'm going to go through pretty quickly, so you can pause this thing and fill it if you'd like as we go. But here is the population distribution, and then these are the summary statistics of these 5 scores. So these would be the parameters, because these are the statistics for this population. The mean is 80, the standard deviation is 15.811, etc. Okay, the range is 40. Now, we want to take a sample using 2. So I want you to actually do this. Randomly choose 2 of the 5. I've done this already, and my random selection had chosen 70 and 60 as the 2 scores, which meant that my sample's mean, X bar, sample mean, was 65 for this sample. Okay? So then the next part of this is to, that's just choosing one sample, is what happens if we looked at every possible sample? Now in this case right here, 5 choose 2, there are 10 possible combinations that can happen if we're choosing 2 out of 5. And so here they are. This order doesn't matter. 70 and 60 is the same as 60 and 70. So these 6 samples, these are the 10 possible sample means that can occur with a sample size of 2 from a population of 5 with those data values. Okay, so the next thing I'm going to do is going to make a dot plot of these 10 values and then find their summary statistics. So each of these dots here, these are sample means. That is going to be the sample of the one that had the 60 and the 70 together, for example. Okay, so those 10 sample means have a mean of 80 and a standard deviation of 9.21. Its range would, the highest value is 95, the lowest value is 65, so that the range of those sample means is 30. So what was the mean of the sample means? 80. What was the mean of the population? 80. Take note. That will come up again. All right, and label it on the one above. Okay, here, the sample mean is 80. Okay. Now, what if we changed our sample size to 3? Well, now there would still be 10 samples. This is just because of how the 5 choose 2, 5 versus 3 checks out. There's still 10, but I would end up with these. 60, 70, 80, 60, 70, 90, 60, 70, 100, etc., etc. There's 10 combinations of choosing 3 out of a population of 5. And then these, therefore, are the sample means, which creates this distribution of the sample means when n is equal to 3, and then, therefore, these summary statistics for n is equal to 3. The standard deviation of this one is 6.086, and the range is 90 minus 70, 20. Okay. Sample size of 5, the next bigger sample we can take, or sorry, the population size would be 4, because if we choose all 5, then that's the whole population. That's a census. So there's only 5 ways that you can choose 4 out of 5 things. So here they are. So we have, here's the distribution of all of those combinations with the summary statistics. Okay, now the whole point of this is to try to help you understand, first of all, what in the world is a sample distribution. sampling distribution, and it's these. We've actually seen three of them. A sampling distribution is the distribution of all possible samples of a given sample size. So this here is a sampling distribution of n is equal to 2. This is a sampling distribution of n is equal to 3. And this is a sampling distribution of n is equal to 4. Okay, so these are all examples of sample distributions. Now go ahead and start thinking about this. This is not very hard to do, but what happens when your population is bigger than 5? Well, even y'all, if I had there's 16 of y'all in the class, 16 choose 4 all of a sudden becomes hundreds, and that's still a pretty small population, right? So creating a sampling distribution is going to be very difficult, but we're using this very simple situation to help us understand some key ideas of sampling distributions. But these are what they are, the set of all possible samples of that given size, the sample means. All possible sample means of that sample size. So let's compare these things. The parameter of the average of those 5 scores was 80. The standard deviation was 15.81. This would be if we had done 5 choose 1. If we'd said let our sample size be 1. Well, we'd have had 5 possible choices, and that's what we would have gotten, those values there. Just by the way. Look at what happens with all of the sample means. These are the means of the sample means. And then these are the standard deviations of all of those sample means of the sampling distribution. So, what do you notice about the means and about the standard deviation? It should be pretty obvious. Okay, what you should notice is this. Here's the key takeaway. The mean of a sampling distribution is equal to the population's mean. In other words, the mean of every possible sample mean with the particular sample size is the population's mean. Sampling distribution's mean will equal the population mean, and this becomes huge. The other key takeaway right here is that as the sampling size increases, the standard deviation of the sampling distribution decreases. As sampling size increases, variability decreases. Okay, so again, what is a sampling distribution? The set of all sample means of a given sample size. Okay. Next, sampling variability. We've talked about this in first semester, but here's what it is. Sampling variability, or sampling error, is what we call it when a sample statistic does not equal the population's parameter. It does not mean that we've made an error, it's just that the sample is not accurate. So what does this dot mean? Where is this? This dot here at 90. This one is the one that we're asking about. This one. This dot here. What does this mean? That is the one sample's mean that was chosen from the 80 and the 100 being chosen. So the 80 and 100 were chosen in that one, and so its sample's mean was 90. Was it accurate? Well, no. It didn't equal the sampling, the population's mean. Does that mean that there was bias? No. Not really. What it means is there was sampling error. There's sampling variability. That's when the sample does not equal the population. So was it accurate? Well, of course not. Does it mean that it had bias? No, there was nothing wrong with that sampling process. It was done perfectly randomly. However, the sample itself was not perfectly representative of the population. That's sampling error. Okay, finally, bias versus variability. I love this diagram that's in our book. This is what high bias and low variability looks like. So are we getting close? Are we close to being accurate? No. So there's a lot of bias. The samples are not representative, but there's low variability. Here, Is there a lot of bias? Well, no, not really. They're all around the center, but there's a lot of variability compared to the D down here. This is the one you want, of course, right? This is high bias, low or sorry, very low bias and low variability. And then this one is where we would have high bias and high variability. So just a comparison of these things. Which one do we want? Well, clearly you want this guy. You want low bias, high variability. However, but what's the next best thing? This guy. Bias is the death of samples. In other words, is really what this is about. But bias versus variability is just an important distinction of this. All right, so the key terms are, what is a sampling distribution? What happens to the mean of a sampling distribution? It equals the mean of the population's mean. And what about the standard deviation of a sampling distribution? As the sample size increases, variability decreases. Sampling error is just simply something that happens with sampling where we don't equal the population's parameters. And then what is the difference between bias and variability? There we go. We're going to hit the ground running. I hope y'all are doing so well, and I will talk to you soon.